All right, so today we're going to be learning about exceptions to the octet rule. If you guys remember, octet rule is basically just a rule that tells us that everything wants 8 electrons, right? That's kind of how we've been drawing all our pictures. Now we know one of the exceptions, and the first exception that we know already is that hydrogen wants 2, right? But today we're going to learn 2 more exceptions, and that's going to be pretty much it. The first new one is this one right here. And it's that boron wants either 4 or 6, okay? So the first exception we're learning is boron, element number 5. It wants either 4 or 6 electrons, okay? So that's the first rule, or the first exception. Make sure you guys are jotting this down because you'll want this as you're doing your assignment. And then the other exception we're going to talk about is that elements that are row 3 and under, they can hold more than 8 if they have to. Okay, so we know that on the periodic table we have, you know, the rows, right? And so on the rows, anything that's 3 and under is going to be able to hold more than 8. So anything starting from here, usually with phosphorus, 3 and under, they can hold more than 8. So starting with like phosphorus, sulfur, chlorine, things like that. So they can hold more than 8 valence electrons. Okay. So the numbers that they usually go for are going to be 10 and 12. You're not really going to get odd numbers. So keep that in mind. Anything third row and under, so phosphorus, sulfur, chlorine, and then anything underneath those. Yeah. All right, so that's all the new info. We're just going to do 3 practice problems just to make sure that you guys got it, and it'll be helpful for your assignment today. So I'll leave this up here so you guys can keep copying it down. But let's get started with our first practice problem, and that's going to be drawing SF6. Okay, so if we take a look at SF6 on the periodic table, let's look at S first. Whoa, what's that? So S, we're going to count the boxes on the periodic table, is going to have 1, 2, 3, 4, 5, 6 valence electrons, and F is going to have 7. Okay, so S has 6 and F has 7. So let's jot that down. S is 6. F is 7, but there's 6 of them, so it's going to be plus 42. So we're going to be working with a lot of electrons here. We got 48 valence electrons. Okay, so now that we counted the electrons, we can start making the structure. Now we don't have any hydrogen, so we don't need to use this rule. There's no carbon or silicon, so we don't need to use this rule. So we need to figure out what goes in the middle. And so what we're going to be doing is we're going to be using this rule right here, that more electronegative elements, they want to be on the outside. So if you guys don't remember what electronegative means, basically elements that are higher and more to the right on the periodic table, those are the ones that are more electronegative. So the higher it is and the more to the right on the periodic table an element is, the more electronegative it is. So we have S and F, right? So if we take a look at S and F on the periodic table, oops, wrong one. Which one is higher and more to the right? Yeah, F. So F is going to be more electronegative, which means that it wants to be on the outside. So we're going to organize everything so that we have S in the middle, and then F is going to want to be on the outside. Okay? Something like that. And the reason why is because F is more electronegative than S. Okay. All right, so let's start connecting everybody together. So S is in the middle, so it's going to make connections with the F's. So they all link up with S. So if we make those connections, we drew 1, 2, 3, 4, 5, 6 lines. Each line is 2 electrons, so that's going to be 12. So we got 36 electrons left, and F wants 8 each. So it's the same as normal. We're going to add 6 to get them all to 8. And then since there's 6 of them, that is going to get F to 8. And there's 6, so that means we used 36 valence electrons, so that's all of them. And so there you go. That is the structure for SF6. Now, if you guys take a look at it, S has more than 8 valence electrons, right? It has 2, 4, 6, 8, 10, 12. But that's okay because this new rule that we learned, anything 3 and under, row 3 and under can hold more than 8. So S is in row 3, so it can hold more than 8 valence electrons. So there you go. That's your structure. So not really doing anything new, basically the same thing we've been doing. We're just doing some molecules now where it doesn't always follow that, everybody wants 8, the octet rule. Okay. Any questions on this one right here? Okay. One thing I do want to mention about F in particular, and this will be helpful as you draw your structures later. F, it only wants one single bond. It's kind of like hydrogen. So if you want to jot that down somewhere just to make it helpful. So F always wants one single bond. Okay, unless it has to make a different type of bond, it won't. So F usually doesn't have doubles and it really doesn't like having triples. Okay. So typically F wants one single bond, and that'll be helpful as you do more of your structures and they get more complex. Okay. You guys ready to try one on your own? Kinda? Yeah, what's up? Valence electrons? Yeah, or VE is fine too. Okay, let's try another one. So I have the rules, the new rules written for you, so you guys don't need to feel stressed about that. But let's take a look at this one right here. I want you guys to do BH3. See if you can take about 2 minutes to do BH3. And then after that, we will go over together. And then we have one last problem together, and I'll have you start on your assignment. So I'll give you guys another minute to finish up that one. Alrighty, guys. So if you're finishing up, feel free to finish up that structure, but I'm going to start going over it. So B, if you take a look on the periodic table, has 3 valence electrons, and then hydrogen has 1. Okay. So we're going to count up the electrons. So B has 3, hydrogen has 1, but since there's 3 of them, 3 plus 3 is going to give us 6. Okay, now we're going to follow this rule right here. H wants to go on the outside, so that means B is in the middle. And then we're going to connect everybody together. So H only makes 1 bond, so you connect them to the B. And we used 2, 4, 6 valence electrons. So there we go. We used up all of them. Now B, you might think, is not happy because it only has 6, right? But remember the rule that we just learned. B can be happy with 6 electrons. So it's going to want to only have this. So there you go. That's BH3. Any questions on that one? That one should be pretty simple. All right, we'll do one more, and this will be the hardest one that we go over today. And then after that, I'll have you guys get started on the assignment. So I'm going to do this one with you guys, but if you guys feel comfortable, you can kind of go ahead and finish it up on your own because I will be taking it step by step. But yeah, let's go over this one right here. SO4 2 minus. So we're going to start by counting the valence electrons. So let's start with S. S is going to have 6 valence electrons, and oxygen also has 6. So they both have 6 valence electrons. Okay, so S is going to have 6, and oxygen also has 6, but there's 4 of them, so that'll be plus 24. Okay, now, if you guys notice, there's a -2 sign, right? And so if you ever see a negative sign next to a formula, it means that it has gained electrons, okay? So gained electrons. So if it's -2, that means we're gonna add 2 electrons to our total count. So if you see plus, that means you lose electrons. If you see minus, you gain electrons. So that's why we have +2. Sorry, what? Oh, okay. And then that'll give us 32 valence electrons. Okay, so just be careful with those minus signs. It means there's more electrons to work with. Okay. All right, so there's no hydrogen, so we can ignore that rule. There's no carbons or silicon, so we can ignore that rule. Instead, we have to use the more electronegative rule. So remember, electronegative ones are the ones that are on the top and to the right. So if we take a look at S and O, which one is more electronegative between the two? Yeah, O is more electronegative because it's higher. It's not more to the right, but it's higher, so it's more electronegative. So that means O is more electronegative. So O is more electronegative. And that's because it's higher than S. All right, so now we can just start organizing them as a structure. So O wants to go on the outside, so we'll put the 4 oxygens on the outside. S goes in the middle. Let's connect them together. So 2, 4, 6, 8. We used 8 valence electrons. And so that's going to bring our count down to 24. And then oxygen wants to have 8, so we're going to put 6 on each of them. And if we do that, that is going to use up all 24 of our valence electrons. And that's it. Now, one thing I do want to mention is that if you ever see a negative or positive sign next to the molecule formula, what you have to do on top of drawing the structure is you need to put it in brackets and write the charge next to it, just so that the person who's looking at it knows that you're looking at an ion. So in this picture, everybody's happy because everybody has 8. Now, before I let you guys go, I do want to mention that this is just one way to do it, because if you remember, S is in row 3, right? So S can actually hold more than 8. So you can actually redraw or draw this picture differently. And you can do that by putting S in the middle. And what you can do is you can make a double bond with 1 of the oxygens or 2 of the oxygens. And if you do that, you can still create the same structure while maintaining the rules, because S can hold more than 8. Now, you don't have to do this, but this is another way to draw SO4 2-. Because if you look at this, S has 2, 4, 6, 8, 10, 12. But since it's in row 3, it can actually hold more than 8. So that works as well. So that's just to say there are multiple ways to do this. So just make sure that when you're checking your answers with my answer key, that you just make sure that if yours is a little bit different, it's okay, as long as it's following all the rules that we talked about. Okay? Alrighty, so I'll give you the rest of the class period to work on the assignment. If you have any questions or you want to check your answers, let me know. But yeah, I'll give you the rest of the class period to work.